In the last video, I presented web apps as an alternative to native mobile development. The single biggest objection in the comments was about Electron, the assumption that web apps are fundamentally broken and always result in enormous bundle sizes and poor user experience. Well, I dislike Electron apps as much as you do, to the point where I can tolerate only a couple of them on my Mac, and the smallest one is nearly 500 megabytes in size. But here's my web app. It's under 10 megabytes and rated 4.9 on the App Store. In this video, I'll explain the difference. More importantly, I'll show you how to build web apps that offer a user experience comparable to Swift UIs and a developer experience that's far better than Swift UIs. Oh, and you can deploy such an app in 3 minutes and without getting an approval from Apple or anyone else. Does that sound too good to be true? You're right to question this. Replacing Electron with WebKit wouldn't magically make your app better. The web stack is full of hidden friction points that make unoptimized web apps feel wrong to mobile users. So when you want a product that has the look and feel of a native app, first you have to make sure that the web app itself is fast, powerful, and responsive. And that's what we'll focus on today. No native shells, no pinning to the home screen, only a plain website. But one that runs better than half of all Swift UI apps, and better than 99% of all vibe-coded garbage. This video is not a coding tutorial, because you don't need my help to write a JavaScript function. Instead, I'm offering you a deep dive into my app's architecture. I break down its key aspects, explain my design decisions, and offer architectural advice you can apply to your next or your first web project. And if you've got channel membership, today's extras include expanded explanations, more examples, and a detailed breakdown of my deployment process. If you don't have a membership, no worries. The public version of this video still includes everything important for getting started. In case you missed the last video in which I explained the app's concept, Space Photos is my playground project. It's a simple app that presents images of the universe fetched from NASA's Astronomy Picture of the Day service. It is super fast, works on screens of any size, and lets you build a collection of your favorite pictures. In terms of software, Space Photos is built as a progressive web app. It works in the browser as a plain website, on the home screen as a pinned app, and in a lightweight shell as a native iOS app. At each level, it gains more native-like features. The web app is completely self-sufficient and keeps everything in a single repo. That everything includes the actual metadata for each space photo, its title, explanation text, and media URLs. In a larger or more complex app, I would probably keep production data in a separate place, perhaps a dedicated database. But in this case, storing the JSON files in the same repo enabled faster builds and some useful build time optimizations, while taking just 13 megabytes for over 30 years of space photos. At this point, it seems that I can no longer avoid answering the question I got asked multiple times in the comments. What specific front-end framework Space Photos is built with? I didn't name it in the last video, because doing so requires providing enough context. Now's the time. I always say that any technology is just a tool, and you should pick the best one for your specific job. I even put this in the channel description. So let's first consider the functional and non-functional requirements of Space Photos. First, if I want even the slightest chance to compete with native apps, the framework must incur as little overhead as possible while playing nicely with all the modern web standards. Second, because this was actually my first serious web app, I didn't want to commit to any single framework, just in case I'll need to swap it for something else later. That is why standard HTML syntax was preferred over any specialized tools like JSX. Third, I enjoy clear separation of concerns, where business logic is or can be entirely decoupled from the user interface. Only when I had this list of requirements did I actually start looking at my options. And while more than one framework matches this criteria, for this specific project I chose SvelteKit. Here's why. First of all, SvelteKit is not really a framework, but more like a compiler. SvelteKit compiles down to vanilla JavaScript and has no virtual DOM. At runtime, it is nearly as fast as bare handwritten code developed 30 years ago. The bundle of a fully functional app is roughly 50 kilobytes in size, or about half as much when it's gzipped. SvelteKit syntax is based on standard HTML. You don't have to learn some new JSX or XML-like language, so if you decide to switch to a different framework in the future, you can reuse most of your code. SvelteKit does not enforce any particular design pattern, but it fits the MVC and MVVM patterns quite naturally. My personal preference is to do as much as possible in the server components, which are roughly equivalent to the controller and MVC. Although in my app they're not really server components, but rather build-time components. My app is fully pre-rendered, which is another advantage. The data flow is reactive, which is something I was cautious about at first, because of my poor experience with SwiftUI. But in reality, SvelteKit's reactivity is much more fine-grained. It doesn't update entire screens whenever something changes. Instead, it's based on individual signals you're subscribed to, similar to Cocoa bindings. And finally, I find SvelteKit's out-of-the-box experience very dev-friendly. It ships with full support for routing, server-side rendering, static-side generation, and many other things. If you only need the reactivity and reusable UI components, you can use Svelte alone, without the kit. But so far, I've been quite content with the features and developer experience of the entire framework. One aspect of that developer experience I should highlight specifically is the support for hot reloading. This isn't something unique to SvelteKit. This feature exists in most front-end frameworks. But I just can't stop appreciating how stable and reliable it is. Updated pages refresh instantly and even keep any user input intact. But if there's a syntax error, you'll get a warning immediately. Try to achieve the same in SwiftUI. By the way, maybe you heard that story where Apple accidentally leaked the sources of the App Store's web version. Guess what front-end framework is built with? That's right. So, moving on from the developer experience to the actual development process, let's have a look at the core of Space Photos. First, the overall approach to the app's layout. When you want a good mobile app, you should build a mobile version first. A single viewport directive disables the standard zoom-out behavior, sets the scale to 100%, and lets you use the screen parts outside the safe area. The latter will be important when you run the app in the standalone mode with no browser toolbars. Because I wanted to minimize the friction for my app's existing users, I decided to sort of imitate the familiar look of a typical iOS app. This means my app should have a tab bar on the bottom and a navigation bar on the top. Both are simple panels that sit above the main document and are pinned in place using the fixed position mode. Importantly, because I made the panels appear semi-transparent and have a blur, the page content must scroll beneath them. Both goals are easily achieved with only a few lines of CSS. You see, HTML documents can be infinitely long, which turns the browser canvas into a giant scroll view. When you reach the end of it, the entire document, including the bars, would exhibit rubber banding and can also trigger a page refresh. This is what immediately gives away the true nature of the app. In native ones, the bars always remain stationary, while the content can scroll, stretch, and bounce back. And that is exactly how it works in my web app. Things like this really do matter for the overall user experience. And actually, they're not impossible to recreate, you just have to care enough. For example, I once had to subclass the UI components of Firebase in app messaging and extend them with native-like interactions. I used UI kit dynamics to add physics-based rubber banding and swipe to dismiss. It took me quite a while to figure out the precise formula, but the resulting animations felt very familiar to iOS users. They didn't have those uncanny valley vibes you often get with cross-platform frameworks. By that point, Space Photos looked just right on mobile. Bringing it to larger screens required only a couple of adjustments. First, I limited the container's maximum width to 800 points. I did it so the UI doesn't feel absurdly wide on large monitors. This takes exactly one line of CSS. And second, I configured the tab bar to move from the bottom to the top when the width exceeds a certain threshold. This required only a couple of lines too. The next point is the look and feel. As I mentioned in my previous video, every UI element of Space Photos works equally well with all input methods: touch, mouse, and trackpad. In most cases, I didn't even have to do anything special because nearly every HTML element adapts correctly out of the box. But there's a catch. You have to use those elements according to their semantic roles. For instance, the button element on the web is not really designed to take the user elsewhere. Its purpose is to perform some local ephemeral action: open a menu, expand a section, close a model sheet, and so on. And while it's totally possible to trigger navigation using buttons, this negatively impacts accessibility, which is quite important. A more conventional approach is to use the standard anchor element, also known as the link. You can style it to look just like a button, with background, padding, and whatever else. Doing so automatically enables the behaviors you associate with links: the hover and active states, the pointer cursor, and the ability to open them in a new tab. The button can do this without a lot of extra code. This is why most elements that look like buttons in my app are actually links. This includes the tabs in the tab bar, space photo cards and thumbnails, and cells in the favorites list. There are still places where I used plain buttons, mostly because I needed to trigger haptic feedback, but I'm working on turning them back into links. Another aspect is navigation. A typical single-page app, or SPA, is just that, a single page. This offers the exact experience many of you associate with web apps, and I admit, it's not a good one. First, the SPA shows an empty template. Then it displays a loading indicator and starts fetching the data, which takes 3, 5, 10 seconds or even longer. Then it shows the content, often after a flash of white or a jump in the layout. At that point, you can finally see the content and interact with it. You can even navigate to other screens, or so it appears. To the browser, all this is just an opaque box that's doing something. Every screen of the app has the same URL, so you can't easily go back or share a link with a friend. And web search engines really hate this setup. It didn't work for me either. The whole point of taking space photos to the web was to make each photo easily discoverable and easily shareable. That is why I implemented navigation the same way it worked 30 years ago. But thanks to the support for client-side navigation in SvelteKit and transitions in CSS, navigation looks much better than it looked 30 years ago. Technically, you can even achieve the push and pop animations from view controllers in iOS. However, after some testing, I decided to use a simple transition, without the entire page sliding over another one. This didn't look good on large desktop screens. As I was working on this video, out of curiosity I checked some of those Mac apps ported over from the iPad. Turns out Apple has removed push and pop from most of them too. Apple News is a notable exception. First, it slides a new view controller over the old one, and then it sends me to the browser anyway. That's true genius of user-friendly UI, I'd say. Again, navigation in space photos does not use some deep links resolved dynamically. These are 100% real links. When you click on one, it shows the content immediately, with no extra loading, as if the space photo was already baked into the physical HTML document. That's because it is. Despite client-side navigation being available, the entire app is still pre-rendered at build time as a collection of standalone HTML documents. That means users can start browsing space photos on any page. And when they want to go elsewhere, client-side navigation takes over and shows new content almost immediately and without a full reload. Implementing this presented one completely unexpected problem. I'll detail it in the bonus section about my deployment setup. But if you don't want to subscribe to channel membership, don't worry. This problem is unlikely to affect you, at least as long as your product doesn't have tens of thousands of pages. Next are a couple of native features. While I'll be breaking down the native shell in a future episode, there are still a lot of features that can make a web app feel more native even without a real iOS wrapper. This time I'll cover those that work right in the browser, even when the app is not pinned to the home screen. The most obvious one is support for the light and dark modes. In CSS, enabling it takes setting a single rule. It works in every browser. Then you have to customize your app's color palette. If you use semantic naming, just like it works in iOS, then overriding color values for the dark mode is a straightforward process. The ability to store data persistently on device is what makes my app stand out, even compared to many native alternatives. Back when it was a UIKit app, I used core data for this purpose, but the web offers a robust alternative. In the end, I was able to migrate from core data to IndexedDB with no loss of functionality and most importantly no loss of data. In a future episode, I'll explain how I moved existing records without users noticing anything. To keep the length of this video reasonable, I skipped sections about accessibility and cross-browser testing. I plan to cover them in separate episodes, so if you're interested, subscribe to the channel. For now, let's assume that your web app works as expected on every major rendering engine. So it's finally time to deploy it. To keep space photos easily maintainable, I wanted to limit the number of external dependencies. That is why, instead of building a live API backend, I decided to deploy the app statically. As I already mentioned, SvelteKit supports pre-rendering and static site generation. Building my 11,000 page app takes about 20 seconds on a laptop, but obviously production deployments use continuous integration. Overall, it takes GitHub Actions about 3 minutes to check out the repo, install the dependencies, build the project, package it for distribution, and deploy it to Cloudflare pages. Hosting a static site at the edge results in unmatched loading speed. And with a couple optimization tricks explained in the following bonus section, many navigation actions don't even make extra network calls. Did you notice one thing that's absent from this deployment process? It's the App Store submission. While Apple has greatly reduced the average review time for iOS apps in the recent years, it doesn't come close to my 3-minute deployment. There will be one important section right after this one, but at this point, I believe I've covered all the important aspects that provide a foundation for web apps that look and feel just like native apps, if not better. As for the developer experience, I think you'll agree that it's much better than the Swift UIs already. In the next episode, I'll cover the things that turn a regular website into a true progressive web app. If you've got any questions or advice, I always welcome them in the comments. Just one request, please keep your temper. Claiming that WebKit on iOS is bad just because you don't like Electron apps on your PC sounds kinda ridiculous. That's not what I would expect from senior engineers. Speaking of Electron. Just before we wrap up, I will address one giant misconception I didn't pay enough attention to in my concept overview of PWA. It sounds like this. You're selling me an Electron app. I hate Electron apps. Everybody hates Electron apps. Electron apps. Ah! You don't like Electron apps, and rightly so, but you blame the wrong part. Electron's problem is not the web app inside, it's what surrounds it. Every Electron app comes with a full copy of Chromium and all its dependencies, plus a large collection of native bindings to handle every use case on every platform. This results in enormous bundle sizes for simple apps like chat clients. Installing a new app literally adds another Chromium instance on your computer. In contrast, WebKit is a system framework. Instead of copying it, apps link against WebKit dynamically. As for those native bindings, you only implement what you will be using. There are frameworks such as Cordova and Capacitor, but I decided not to use them in Space Photos, precisely to keep its size under control. These two differences dramatically reduce the bundle size. For instance, my app is under 10 megabytes, most of which are actually static resources like the launch screen image. At runtime, each Electron app starts its own separate Chromium instance complete with all the helper processes. Inside it runs your actual web app. If you have two Electron apps running side by side, they use roughly twice the memory. This is like launching a separate web browser for every single website you visit. Now see what happens when you run multiple WebKit apps. Because it is a system framework, its rendering and JavaScript engines can be reused across processes, and they are. The client code, including the DOM tree, the JS heap, and cookies, is still sandboxed to isolate apps from one another. Conceptually, this is just like having a browser with one tab and then opening a second one. Does this result in the doubling of the resource footprint? No, it doesn't. Because WebKit itself is very lean, the product's overall speed depends squarely on the web app that you write. If your code is inefficient, the app will feel slow. But you know who to blame in this case. So the question comes down to whether you're comfortable taking responsibility for your own code. I am, and that is why I'm not intimidated by WebKit, Cocoa, Auto Layout, and even Interface Builder. I know that when you use them correctly, they work exactly the way you want them to, and produce rock-solid, blazing fast results, unlike Swift UI's black box. So it's only a matter of engineering culture, I guess. That's it for today's Codebird video. If you found it illuminating, give it a thumbs up. As much as I wanted to keep this episode relatively short, the director's cut still adds up to over 4,000 words. But I believe this is better than bringing you a high dynamics video with terribly limited perspective. You can't build good products if you operate on simple maxims like native good, web bad. Sorry, but that's just immature. In the next episode, we'll take another step in building web apps that feel like native apps. If you're interested, subscribe to the Codebird and stay tuned. I'll see you in the next video. Until then, make your web apps fly.